For the second video for notes 46, I'm going to continue graphing these linear inequalities. So question number 5, question number 6, and then I'll finish off with number 7, which is going to review quadratic formula. So question number 5, I want to start by graphing the boundary line. So y equals 3x minus 6. If it helps, you might want to put that 3 over 1 so you get the full idea of where slope is. So our boundary line here, we're going to start off at -6 on the y-axis. 1, 2, 3, 4, 5, -6. And then from here, I'm going to follow my slope for my directions. So up 3, 1, 2, 3, and then to the right 1. I'm going to keep doing that. So again, I like doing it a few times so that I can get as accurate of a line as possible. So basically, I just keep doing it until I run out of graph. Okay, so now the next question is your boundary line dotted or solid? And since our inequality does not have an equal to part to it, it's just greater than, we are going to have a dotted boundary line. So when we dot out a boundary line, we're basically going to play connect the dots, but just use dashes, okay? And I tell my students to make it kind of, obvious, so that when I look at it, there's no question that is a dotted line or a dashed line. All right, next part, are we going to shade above or are we going to shade below our boundary line? Now, this boundary line, you might be looking at, what do you mean above and below? There's a left and a right. There is both left and right and above and below. So when we're talking about above, I want you to think about your number line, right? This boundary line here. And basically you are shading literally above it, okay? For below, if you go to your boundary line and then you start drawing these lines underneath it or below it, that would be what you're shading in. So for this particular function, this particular inequality, we have a greater than. So that means that we are going to be shading above our boundary line. So from the boundary line here, this dotted line, right, pick your color of choice and shade above it. All right, that's it for number 5. And this stuff off to the side here, this is more notes to help you get the graph. You don't have to write these out, okay? All right, part B here, all right, which honestly, part A and part B kind of look really similar, don't they? The difference is part A here, we've got greater than, part B here, we have less than, but everything else is the same. All right, so boundary line, we're still going to start at -6. 1, 2, 3, 4, 5, -6. Yep. And then I'm going to count the same slope, right, because this is over 1. So up 3, 1, 2, 3, over 1. I can do that again, and again, and again, and then I run out of graph. The boundary line in this case, there is no equal to part, so the boundary line is still a dotted line. All right, so far, let me give those a second chance here. So far, question number 5, these, right, this looks the same. The boundary line here looks the same as the boundary line there. The difference is going to come in because this is less than, all right? So the less than here, it means we are going to shade, below our line, okay, below our boundary line. So your boundary line right here, you want to shade underneath it or below it. So again, pick your color of choice, shade, shade, shade. There we go. So boundary lines are in the same position for part A and part B. They're both dotted, right? Everything's the same for that. It's just the shading that changes whether you're going above or below your boundary line. All right, so now question number 6. Question number 6 is right format. So let's do the boundary line here. We're going to start off at +4. So 1, 2, 3, 4. And remember, you're always starting off on the y-axis. Now, I want you to be careful with your slope here because while you have a negative, that negative belongs either with 2 or with 3. It is not with both. All right, I need to make sure that this equation has a negative slope. So I'm either going to go down to the right 3, and again, I'll keep doing this until I run out of graph, which is pretty much there, or right? This was going down and to the right, or you can go up 2 and then left 3. So if you make the 3 the negative, so up 2 for rise, and then make the 3 negative, up 2 for rise, make the 3 negative. Notice a couple of things. These points all lie in a single line. So that's a good thing for us. And also notice that your slope was supposed to be negative. And yes, if we play connect the dots, we are creating a line with a negative slope. Speaking of connect the dots, we have an equal to part here. So that is going to be a solid line for us. There we go. So arrows at the end. And our inequality here is less than. So from our boundary line here, we want to shade below it. All right, so pick your color of choice, whatever makes you happy and content. And we're going to shade below. So that's the number 6 problem there. We've got everything graphed out. So now we're going to take a little detour into quadratic formula. So the quadratic formula is listed there, and we want to solve this handy-dandy equation. So as a gentle or not so gentle reminder, this format to solve using quadratic formula, you need it to be ax squared plus bx plus c equals 0, which means for our problem, we're going to have a is equal to 2, b is equal to 4, and c is equal to 9. Okay, so in that format, you just read the variables across, right? Those coefficients across. So let's see what we got here. Now, I happen to know quadratic formula off the top of my head, so use the reference if you need it. I'll give myself a little space so you can see what I'm referring to over here. But as I go through, I'm going to leave space to do my fill in the blanks. So I'm going to do the opposite of b plus or minus the square root, I write huge, that's probably not big enough, but we'll get there, of b squared minus 4ac, told you I didn't write big enough, all over 2 times a. So everywhere I need an a, so a goes here and here, right? There's my 4a and 2a. So I'm going to replace that with 2's. Everywhere I have a b, b is here and here, so here and here. Those are going to get replaced with 4's. And then the one single solitary little c value, which is right here, that's going to get replaced with a 9. Whoops. Apparently I deleted something, so let's go put that 4 back. Hit the undo button, apparently. All right, so now I'm going to zoom in, and let's simplify this mess. All right, and I'm going to simplify in parts. The first part is going to be the opposite of 4, or negative 4. So that's going to be x is equal to, well, negative 4 plus or minus, slightly smaller square root this time. Let's see, 4 squared is going to be 16. And now I need to do negative 4 times 2 times 9. So I'm going to take this apart in pieces. So let's do negative 4 times 2 is negative 8. Negative 8 times 9 should be negative 72. And then in the denominator, 2 times 2 makes a 4. All right. So we've got to deal with just a little bit more simplification. And so let's find out what happens when we want to simplify under this root just a little bit more. All right. So let's see what we got here. We've got 16 minus 72. And if I add that up, whoops, right with a pen. So negative 4 plus or minus the square root of negative 56 all over 4. Okay, so this is fun. So the problem is negative 56, we need to simplify it. And so we're going to need to simplify the 56 using your prime factors or factor trees or whatever you remember. And we've got to deal with the fact that that is a negative underneath there. So I'm going to kind of go off to the left side here. If I've got the square root of negative 56, I'm going to have the square root of 56 and the square root of negative 1. So 56, let's see, what can divide into 56? I think that's 8 times 7. 8 times 7 is 56. Let's go with that one. So 8 and 7. So 8 would be, let's see, 2 and 4, and 2 and 2. So 2, 2, 2, and 7 make up our 56. So 2, 2, 2, and 7. Yep, that works. So let's see, we've got a pair of 2s. So that would be 2. And then the 2 and the 7 here, they don't pair up. They just multiply back together. So that's going to be 14. And then way back at the beginning, we have the square root of -1. So that's going to be I. So what happens here is I just simplify the square root of -56 into 2 root 14i. And so I'm going to do that replacement. I'm also going to take just a little moment here, and I'm going to loop this and shrink it, because I know I write huge, but that was getting ridiculous even for me. All right, so x is equal to -4 plus or minus 2 root 14i all over 4. And you are so close to being done, just a little step further, and here's the little step further. -4, 2, and 4 are all divisible by 2. So you actually want to divide that out. So -4 divided by 2 is -2, plus or minus 2 divided by 2 is 1. So it's going to be 14i. If you want to put the 1 there, you can, in front of the root 14. And then 4 divided by 2 is 2. All right, all that hard work, and that is the exact answer for problem number 7 there. Solving by square root. We did create a problem that had an imaginary answer there. All right, so that's the last answer, last problem here for, I completely forgot what notes I'm on. What notes am I on? Notes 46. There we go. All right, so that's the last part of notes 46. As always, please let me know if you have any questions or concerns, and I will see you in the next one.